Hello. The learning objectives for this module are to 1. Understand what new checks we need to make on anchor sliding, understand what ways in which we can add sliding capacity or more, discover sliding capacity by eliminating assumptions, and 3. Apply engineering judgment to sharpen the pencil on our sliding calculations. Now, equation 4.29, of the manual shows what our sliding driving force will be, as RS equals P active, so the earth pressure plus pH, which is the horizontal force from the cables on the anchor. And in the following tips and tricks for abutment or anchor sliding, we will make the assumption that the entire abutment acts like a single block. With some force, some frictional resistance, etc., etc. Forces are transferred from the anchor through the ramp walls and into the tiers. We don't actually check or rely on these forces. However, we cannot discount them when we're viewing the entire abutment as a block. So here's an example abutment, and if we're viewing this entire thing as sliding in a block, we need to consider that these forces on the anchor, when we're looking at anchor sliding, will get transferred through the ramp walls and into the tiers, as well as forces on the tiers or the tower are then going to pull on the anchor. And because of that, we need to include this pH tower term. This was discussed a bit in the cable analysis section. And remember how sliding force on the anchor are less because there are friction losses at the tower saddle. They just don't go away. It is transferred into the abutment from this pH tower term. And to calculate pH tower, we're just going to use color. Air pH on the main span minus our pH backspan, assuming there's some friction transferred across the tower, and that's going to be the pH backspan hand and pH. And walkway. So basically, if we're looking at the tower here, we're going to have our main span forces. We're going to have our backspan forces. And the main span minus the backspan forces is going to create that pH tower term.